Hi guys. So I wanted to make a video on one of the questions of the calorimetry, which is like really close. This question actually like really close to your question 7 of your homework. So basically, what the question says is a 98 grams bullet is fired from a height of 296. Initial speed of the bullet is 189 meter per seconds, and it comes to rest in bucket containing 2.1 kgs of the benzene. Now you have to ignore the air drag and the potential energy. So one thing that I was thinking was, if they gave us the height, why are they asking us to ignore the potential energy? And if we're ignoring the potential energy, then how is this height useful? Then I ponder of the question. The question says, find the impact speed. What is impact speed? Impact speed is as if basically how like the speed at which the bullet it crashes into the bucket, right? That's the impact speed, right? Okay. Now, so we could consider that as a V final, right? Impact speed as a V final. Okay. Now we also have V initial, right? Okay. Perfect. What else do we have? Since it's going down, right? So we could say, well, acceleration should be negative 9.8 meter per second squared. Okay. And then we also have this height. So so since we don't want to use this height for the potential energy, how else can we use it? So if you think for a second, this height is basically also the distance traveled by the bullet, right? It's also the distance traveled by the bullet, right? So we could call it as its displacement. So negative delta R is negative 296. Since we're coming down, right? We're coming down the height, right? So it should be a negative, right? Um, okay. So we have all this data. We have initial speed. We want to know the final speed. We have acceleration and delta R. So how could we like mend them together to find the displacement, to find the final speed? So if you go back to kinematics, you're going to have an equation that says V final squared equals V initial squared plus 2A delta R, right? So here, the V final, we want to know the V final squared, right? But do we have the V initial squared? Yes, we do. That's 189. So 189 squared plus 2 times negative 9.8 times negative 296. If we solve this, we're going to get 109. So we get 41558.12 here. So this means let's basically take the square root to cancel this square out. I'll just take the square root and we get 204 meter per second. So this is how you're going to calculate the final not the final but the impact speed, like the speed as like just right before, like some seconds before the bullet hits the, not second, like exactly before the bullet hits the bucket. Okay, now let's go to the second part of this question. So the second question says, find the change in temperature of the bucket, right? Okay, what does that mean? Let's draw it. Suppose this is a bucket, right? And then we have the bullet that's almost there, right? Okay, so ask yourself, um, um, since we're ignoring the potential energy, so the only energy that we have here is going to be the kinetic energy, right? So for if we use the kinetic energy, well, it's a big question. What speed are we going to use? Are we going to use 189, or are we going to use the new speed that we get, which is 204? So if you think logically, basically, the energy change in the bucket should be more relevant to the energy of the bullet when it was closer, right? When it was when it was like really close to striking the bucket, and not that when it was far up in the sky, right? So if we think logically, it should be true, right? So that's why we're going to consider 204 as our speed. So let's write it down. Half mv squared equals this should be so q equals m delta c, so q equals mc delta t, or this mass, specific heat capacity, and then change in temperature. So mc. Now you might be wondering, why did we put this equals to this? Well, the thing is, kinetic energy is energy, right? And then Q equals mk. What is Q? Q is also energy, right? So we can put both the energies together, right? Because all the bullets energy is gonna be, it's gonna be like it throws all its energy into the bucket, because it just like final speed, final the, I didn't mention the question, but the final speed of the bullet, like when it's in the bucket, it's zero, right? So that's why um, when the bullet is in the bucket, the speed of the bullet is zero. So that means it that means that all of the energy of the bullet is transferred to the bucket, right? Okay, so let's solve this. So half 1/2 times, what's the mass of the bullet? That is 98 grams. But the mass of the bucket is 22.1 kilograms. So it's better if we convert this grams, the 98 grams to kilograms. So it should be 0.098 kgs times what's the velocity? 204 squared equals um what is the mass of the bucket now? Because we're talking about the bucket. Uh, the mass of the bucket is going to be, it's 2.1. And then we have the specific heat. What should the specific, what specific heat capacity are we talking about? Is it the bullet? What? So if the bullet, it just like it falls into the bucket, right? And the bucket is filled with benzene. What is the thing that's gonna change the temperature? It's it's the benzene liquid, right? So it should be the specific heat capacity of the benzene. And you might have a table in your questions. So the specific heat capacity for the benzene is 1800 joules per kg. Okay, and then times delta T. Okay, if you solve this, you get delta T as 0.538 Kelvin. Hopefully, this makes sense. And if you guys have any questions, you can always email me and confirm anything or ask anything that you guys don't understand. But thank you for listening.